magnetism, investigation 15.1. The supplies for this one are pretty simple. You'll find the compass. You may have some of your own, you can use that. These compasses you'll find in the accessories kit. You also want a metric ruler, and then it tells you to grab 2 magnets from a kit. It doesn't tell you where. First, I was having a hard time finding where these would be. I did find if you go to the ripcord generator box, it's labeled, that has a bunch of these inside of it. The plastic top comes off easily. Borrow 2, just make sure that they get put back in there correctly to make sure that it's still a working generator. So I'm borrowing from that to get my magnets. I don't know if they were stored elsewhere, I looked around. Okay, so there's a couple parts to this lab. It's a good data collecting lab, and also it ends with one of my favorite interesting facts that involves magnetism and planet Earth. But to start off with, students are going to do an investigation of how the distance that these magnets can interact with each other at. So just kind of using the ruler, have one set at 0, slowly bring it closer, and then measure. So at what point does the magnet start to move? And so I had to get to 3 centimeters to get them to move. I've had it move at a closer pace before. So that's why it has them do multiple trials. And sometimes you might miss exactly when it moves. So like this one is definitely reaching at 4 centimeters. So sometimes you get 3, 4. That's why it has you do multiple trials. Find the average, which is always good practice for your students. Try it north-south, south-south, north-north, and then the students will kind of investigate, okay, well, they repel this way, attract that way, establishes the basics of magnetism. For the second half of the lab, so it'll ask them a few cool questions about magnetism. Second half of the lab gives you instructions to set up your compass with the needle facing north. And now taking just a single magnet, starting from the end of the ruler and bringing it towards the compass, keeping an eye, once that compass needle moves 20 degrees, and it's got measurements on the outside, which is why I like this compass from the kit. So it's moved 20 degrees, and I'm still, let's see here, I'm 15 centimeters away from this thing, and it's pushing the needle away from the true north. And so it has students kind of mess around with doing the North Pole, doing the South Pole. Now it's swinging the other way. And students can really see, okay, from this far back, this tiny little magnet is pulling on this compass. And so they actually learn, oh, so the Earth has a magnetic field, but compared to this, the magnetic field is pretty weak. This is able to impact what the Earth's magnetic field is doing from pretty far away, which is kind of a cool thing to learn. And then at the end, it asks them a question. It's like, okay, so if I bring the South Pole towards the compass, the red needle, what normally points to my north, is attracted to the south, which means this red is a north part of the compass, but is pointing me to the North Pole of Earth, which means technically our geographic North Pole is actually our magnetic South Pole. So if Earth was a magnet, the South Pole would be facing north, and the North Pole is facing south, which is just kind of crazy. And then you can get into a whole conversation about students where, oh, that it actually is moving constantly, and every few thousand years, it just does a big flip. And students are just gonna be like blown away by all that information. So it opens up a lot of cool conversations that you can have with your students. My most interesting fact about the North Pole being the magnetic South Pole. So pretty cool lab, pretty intuitive, good data collection and all that. So I hope you guys enjoyed that investigation, and I'll see you in the next video.